So last year, I was asked to help our largest Microsoft and AWS customers move to open source solutions in order to help reduce their costs and improve their agility. So one of my tasks was to find executives like Louise and Elliot and meet with our AWS leadership to try to convince them to move to open source, and we would help them with that, like incentivize them and kind of have programs to help them to do that. So when I reached out, it was actually the first time I met Louise. We had dinner, right? And Louise started explaining what they were doing, and I was expecting the typical things. But what Louise said is that, oh no, we don't have that problem. We have multi-region Microsoft workloads that fail over automatically. In fact, it's less than 5 minutes. I'm like, okay, this guy's not clearly a technical CTO. He just must be like, business CTO. So I kind of pressed a little bit more. I'm like, oh, you must mean like open source and when you have Postgres. No. We have Microsoft, an SQL server. Oh, he doesn't really mean failover. Maybe his team's just telling him that they can do this and they really can't. But the more we dug, it was like, no, we're really doing this. And we're not just doing it for one workload, right? We're doing it for a bunch of workloads. So when I heard that, this is on the New York summertime time. I'm like, okay, you guys have got to come talk. If you really can do this, you need to come talk at reInvent. So that's why these guys are up on stage today, right? So overall, the theme for this session is continuous improvement. And that's what it ends up being when we talk to these guys. And what I ask them to do is say, look, you guys are technical. You've been in reInvent before. I want you to imagine that you were here 5 years ago. And what would you tell your former self sitting in the audience? So what tips and tricks do you have? What kind of things that happened that you wish that you would have known or would have happened beforehand, right? And that's why they came here today. So this is what typically happens. This is kind of what I expected when I talked to Louise at dinner, right? As I expected them to talk about a workload that looks like this, which is really cool. It's great, right? It's a Windows workload using 2 availability zones. It has active, passive SQL servers. They fail over between regions. It's just really cool, right? And normally, a customer would say, we want to do this, and we want to have some type of disaster recovery into another region. Can you help us do that? And we'd talk about different solutions, and almost invariably be, we can't afford that, or that's too hard, and maybe it's not worth it, right? And then the next crisis would come up, and then it would be worth it. Does that sound familiar to anybody? Does anyone have a workload like that right now, where you have a Windows workload, I see 2 heads shaking. Cool, all right, awesome. So that is what I was expecting. This is what I heard about, right? Is I heard about how these guys, like I said, are in more than one region. They're failing within 5 minutes. And this is incredibly impressive, right? We talk about this all the time, but almost no one does it in production. And again, I thought, this is going to be, one workload, something like that. No, in fact, they're doing this for 23 workloads in Windows, 297 workloads for open source, right? That's active-active. Active-passive, these guys are doing it for 531 workloads. 531 workloads, active-active, active-passive between these, right? 89 of those are Windows. And remember, 5 minutes failover automatically. Just simply incredible. We love hearing this. We always dream people could do this. But to hear them do it, and hear Louise talk about it, and be casual about it, yeah, of course, that's what we do. You don't know how good you are right at this. So that's why they're here today. So why did you pick this session? Maybe you're interested in how can you achieve 5-minute workloads, right? Well, hopefully you get some pointers on that today. These guys are doing it automatically, right? So again, maybe you hit a build Windows build times. A lot of people, when they're trying to do this, they build the Windows servers, and it takes 40 minutes, 50 minutes to build, and that's a real problem they're getting through. And it's hard to bring things up quickly when it takes 40 minutes to build your server, right? And is there a magic wand they're going to show you? Maybe there is a magic wand, right? We'll see what Elliot has to say. Maybe you've been asked to reduce licensing costs. Super common request for Microsoft workloads. And so I bet you think we're just going to say Linux, right? Almost always that, right? So maybe. Most likely not. All right, so quick round of introductions. So Louise Barbier is the CTO of Verisk Analytics, right? And we have Elliot Markowitz, who is the managing director of DevOps, and myself, I'm the account manager for Verisk. In my previous role, when I first started talking to these guys, I was a Microsoft specialist. So, about Verisk. So, Verisk is the analytic data and technology partner to the global insurance industry. Its advanced analytics and innovative technologies help clients to strengthen their operating efficiency, improve underwriting and claims outcomes, and combat fraud. They also make informed decisions about global risk. So, what is their relationship with AWS and Verisk? So they're one of our largest Windows workloads, like top 50, right, in the world, how much they use Windows on AWS. They've been doing this since 2017, and they have almost 95% of their workloads on AWS right now. They're the leader of FinOps and optimization, and this is a really important one. A lot of companies will put things into AWS, they'll do a lift and shift, and they'll kind of stop there. These guys have been doing continuous operation, but on top of that, their core organization excels at FinOps and optimization. They're always coming back and trying to optimize. It's very rare when we'll come to them and give them an idea that they already thought of, right? So just outstanding. I've worked with hundreds of different companies, and these guys, I think, are the best I've seen. And on top of that, because of that, and because they moved to AWS, they save between $50 and $60 million annually. All right, so we'll do 5 years to 5 minutes, and Luis Barbier, it's up to you. There you go.
Thank you, Chris. I remember that dinner, and I was like, yeah, we're definitely doing it. It's not a big deal. And he was like, no, you got to tell the world about this. I'm like, it's not a big deal. I'm pretty sure everybody else is doing it that you manage. He goes, no, you got to present about this. I was like, okay, we'll do that. So I'm going to talk about how we got there, where we started, and how we got there, where we are today. So we came to re:Invent early on in our journey, and one of the reasons was because we were getting ridiculed by our customers, our executive, our business partners about our outages. We had a lot of outages, long time to resolve these outages. So we had to do something, right? How many of you guys go to these sessions and this is a common theme, right? Lack of timely infrastructure when you want to get a new server up. It's just, you're like, all right, enough of this. Let's move on, right? Let's get this into the cloud, and it's not as easy to get to the cloud when you're in-house data center company. So in 2016, there was an Arctic freeze in the Northeast, for some of us who live in the Northeast, and our chillers froze. Our chillers is like HVAC systems that are in the roofs of all these high rises, and our data center was heating up, and we needed to cool the data center, or we were going to start losing servers, and we had like 2 hours or so before that, and we were all in a teleconference, and someone yells out, "Hey, how about just break the window and let the cold air just cool the data center?" We're like, okay, that sounds like a good idea, but what are we gonna do afterwards? So what we ended up doing, long story short, we opened the elevator shaft doors and let the cool air come through the elevator shaft into the data center to cool it down. But that was the straw that broke the camel's back. And then from our CEO down to everybody, we're moving to the cloud. So that's when our cloud journey started. And from that point on, we decided to embrace the DevOps movement. We were looking at Puppet, Ansible, Chef, and during that time, we came to AWS at the end of 2016. 2017, we spent the whole time, and we focused on automation, right? Whole time automation, and we deployed our first application in September of that year. But we repeated the same stuff, right? So we just did lift and shift. How many of you guys have servers or had servers on-prem with 50 applications on them, right? So we're running websites, APIs with 50 applications on them. So one application takes out another application, and you're troubleshooting. It was his fault, it's my fault. So that we wanted to get away from, right? So With that, our focus was getting the applications out and get into AWS as fast as possible to leverage the flexibility. So in 2018, we had a paradigm shift. And this is where we started to develop the language, or what we call stacks, right? So a stack is application has its own load balancer, its own data store, and its own EC2 instances that can scale. So we did that, and we started to shift all the applications, including the first application that we deployed in 2017, to have their own stacks. And from that point on, we started to say, well, we need a DR region also. So we started to deploy applications into our Western region. And that's when we said, well, we have a set of applications sitting on the Western region, and it's costing us a lot of money, but we're not using it. So we decided to go, started using Route 53 to cut over when we had issues. So what ended up happening was we had a human sitting in the middle to make the decision to trigger what we call a flip to the opposite region. And obviously, when you have a human involved, there's a lot of thinking, right? So, we say, okay, we have an outage in the east. Can we flip to the west? And there's a person sitting there like, I don't want to flip to the west. I don't want to flip to the west. I don't want to flip to the west. And then you say, all right, flip to the west. Oh, it worked. Okay, maybe we should do this a little bit more often. And it happened. It happens now. We started automating it then. We introduced our alerting system. We use New Relic. And New Relic, we get alerts. And based on the alerts, we automatically flip to the other region. So we took the human out the decision-making aspect of it. So now, at this time, we were flipping within 7 to 10 minutes. And our outages obviously went down because we weren't taking a long time to resolve the issues. This allowed us to now work on resolving the issues while customers were still able to process their requests. So at that point, we were like, all right, great, we're in a great place here. And we continue to move more applications over to AWS. And in 2020, our coworker or our colleague told us, hey, why don't we just have traffic go to both sides, right? Because if we don't flip, we're still spending the money on the other side. So we said, all right, we'll look at active-active. So this is when we started working with the Route 53 rule sets. And we worked with first, we did this with the weighted policy records, where we could, the way we started was 10% of the traffic went to our Western region, which is Oregon, and 90% went to the East, which is North Virginia. And then we continued until we got to 50%. When we got to 50%, we were like, all right, we know each region can handle the traffic. Let's just, go geo proximity. So the way we work now is using the geo proximity policy. So if you're in California, you're using our Western data center. If you're in New York, you're using our Eastern data center. So at that point, it was like, all right, great. What else do we need to do? We're active. So next step was, well, we got to reduce the time. So at this point here, we worked with same Route 53, and we started using the health checks. Although the health checks already existed, but the health checks allowed us to flip within a minute to a minute and 30 seconds. And so now when we flip, we're flipping in that time, right? Because our alerts trigger, and then our flips happen automatically based on those alerts. And now we have most of our workload over into AWS. So again, our outage times have started to reduce. Then in 2024, this year, what we decided to do with our Microsoft workloads was introduce flipping our SQL Server workloads. So we run SQL Server, always on availability groups. So when we flip the DNS when we flip Route 53, the application, we also flip the database to start running from the Oregon region. So the Oregon region becomes the primary. And we did that with SQL Server, and then we started doing that with our other databases as well. So we got it down to a minute and 30 seconds. That's where we are now. And our data stores are able to, are highly available, so we could flip traffic over, and so our applications can flip back and forth. And we use the flip very often for migrations. We deploy our applications. We don't disrupt customers. We are able to test in certain regions. And it's not just because of avoiding outages. Is whenever we need to do something that we think might be disruptive to our customer, we will flip to make sure that we don't disrupt a customer. All right, so this is the how much our on-prem cost when we first started in 2016, and down to 2024 where we don't have any more costs in AWS. But what you'll see is that when we moved our on-prem workload to AWS over the next 5 years or more, you can see how much of the costs in the cloud it accounted for, right? Where today it accounts for 32% of our total costs on AWS. But again, this also allowed us to acquire other companies, either on AWS already or we moved them to AWS. And as you can see over time, that started to grow. And then we have new builds, new business, new innovations that we're able to leverage from AWS. And as you can see here, in 2017, there wasn't much new builds happening because as an organization, we were focused on moving to AWS, or our business folks decided to limit on the new initiatives that we will go after and save it for later on as long as they could. As you can see, in 2023 was a big boom. So there's a lot of stuff got added in that was in the backlog. And then as you can see now in 2024, it makes up the majority of our AWS spend. So all in all, moving from on-prem to AWS accounts for 32% of our total costs today. And then our outages, as you can see, starting in 2020 is when we started recording the downtime hours. We've dropped significantly since we are flipping and we started going active-active. And today we're looking for a 77% decrease in 2024. Now, CrowdStrike. Who's heard of CrowdStrike? Everyone had outage. Remember that? July. So in July, once we understood what the outage was, we have 6,200 stacks, right? That's what we call stacks. We just tore them down and we just brought them right back up to start serving our customers. And within an hour, we have 55% of the stacks up. And within 2 hours, we were at 95. The last 5% took a little longer, and we've revisited it to see how we would improve that process. But those applications were a little tougher to bring back just because they didn't follow they were still in the lift and shift mode that we have to get back to get them into the active-active or active-passive mode. With that, I'm gonna hand over to my colleague, Elliot.
Thanks, Luis. All right, so the end, right? Happy ending. Verisk is doing really cool stuff for their customers. They're able to go active-active. Outages are down. Happy story, right? Well, until you realize that when you run multi-region, it means you're now paying for the application twice, right? That's probably the #1 complaint people have about running their application in multiple regions, is that now I got to pay for it 2 times. Even though you're saving money compared to on-prem, it still hurts when you have to have running in 2 different places. Additionally, AWS has a lot of features that we can use to keep these costs down. Things like dynamic scaling, predictive auto-scaling, all sorts of things like that. But they all depend on rapidly adjusting to changing dynamics in customer requests, right? Handling spiky workloads easily. Windows is just not built for that, right? We're all .NET people. .NET mostly runs on Windows, and it just isn't built for that sort of speed, right? Anyone built a Windows EC2 that took more than 30 minutes to come up? How about an hour? Okay, so we were normally 40 minutes, right? 40 minutes was the magic number for us. It took about 40 minutes to get an EC2 up and fully configured and ready with the application ready to take traffic. 40 minutes is not going to cut it when you have to scale quickly. If you can go out and get dinner and come back and the server's still building, that's too long. So we had to do something about this. So this became our new mission, right? How can we either keep the costs down for the Windows EC2s, or how can we make Windows go fast enough that way we can take advantage of what AWS has to offer? Okay, so the first thing we tried to do, admittedly, we tried to cheat, right? We tried to use a less expensive instance type. Now, I don't mean smalls or mediums. Luis earlier talked about the paradigm shift that we had, right? So we're already running 1 application per EC2. So I'm not really talking about smaller instances. I'm talking about spot instances, right? So the idea was, let's take our backup region, let's fill it up with spot instances, because most of the time traffic's not going to be there anyway. Maybe we can even use a mix of on-demand and spot in our primary region, save some money. If spot's really as cheap as they say, and we've all seen the ads, right, say 90% off with using spot, right? If it's as cheap as they say, then you can even go 2 for 1, 3 for 1. You can have extra spot instances, and even if you lose one, who cares? You have extra to keep the cluster running. The problem is this didn't really work. Now, there are 3 factors that you have to consider when you're thinking about the cost of a spot instance. There's the operating system, there's the region, and there's the instance type. Now, AWS has published dollar amounts and reclaim rates for all this. None of this is a secret. It's all out there available to go look at. The problem is if you're running Windows, immediately you've got that licensing fee. So automatically, that 90% off, forget it. You're not getting that with Windows. It's just not going to happen. Additionally, we had to worry about reclaims. Now, I mentioned the reclaim rate. We get enough to overcome it. But spot is spare AWS capacity. We have several hundred, even thousands of EC2s and different auto-scaling groups that we're running in our environment. And they all, for the most part, were running the same group of set of instance types. So what would happen is we would lose a spot instance, and then the auto-scaling group would give us a message that says, unable to fulfill request, not enough spare capacity. That can happen. And it did happen to us. So we started losing instances, and we wouldn't be able to refill the instance. Additionally, we weren't saving enough money to make that pain worth it. We actually saw better savings using reserved instances and spot and savings plans. So this didn't really pan out for us. So we said, OK, cheating's not going to work. Now we've got to roll up our sleeves, and we actually have to do some work. So we said, how can we make these instances build faster? So we looked at EC2 Image Builder. The EC2 Image Builder allows you to take all your application dependencies, .NET, IIS, MVC, third-party tools, frameworks, and you package them and you install them all on your AMI, on your EC2 image. Now, you could do that yourself, but the advantage here is you use automation to do it every month. So when Patch Tuesday comes out, and Microsoft releases those latest security patches, every month you're slapping all your hardware, all your software requirements on top of that, and you're good to go. And every month you're getting a new image that has everything you need. Now, there are several shops that will actually install the application directly on the AMI, but we have several hundred, over 1,000 applications. It just wasn't feasible for us to do that. But we did use Image Builder, and we started installing all our third-party dependencies on there, and it helped. It started bringing the time down, and from 40 minutes, we're down to now in the 30-minute range. So things were off to a good start. We're moving in the right direction. So now that we're building faster, we asked ourselves, can we launch our instances faster? If you've ever driven in traffic and you're trying to get to a highway, and you can kind of see the highway off in the distance there, and the cars are zipping by, and you're stuck here at a red light behind other cars in traffic, and if I could just get there, I know I can get moving fast. That's kind of what it feels like waiting for your Windows instance to come up, right? Once the instance is up, your application can take over, your code can take over, and you can optimize it as much as you want. But while you're waiting, it's just painful, right? So AWS has a feature called Windows Fast Launch. They released this relatively recently, I want to say maybe a year or two ago. It's actually very, very simple. You just have to check a box on your AMI to enable fast launch, and then pick how many launches per hour you expect to need. So if you're not doing too many, maybe it's 5, you could use 10, 15. What's going to happen is they're going to launch these instances for you of that AMI. They're going to take a snapshot and then terminate the instance. So that way, when you're ready and when you actually need an instance of that AMI, the instance is they were just restoring the snapshot and you're off and running. So it definitely makes things come up faster. Now, a few things to factor in here and consider. There is a small cost hit because you have to pay for the snapshot storage. In our experience, it was trivial. It was not much. It's inconsequential. But again, something to keep in mind. The other thing to consider is that it only works if you have enough snapshots available. So if you have 5 snapshots, you configured it to do 5 snapshots an hour for this AMI, and you launch 6 instances. Well, the first 5 will come up fast. The 6th one will still work. It's just not going to take advantage of fast launch. So it's just going to come up slower. You need to give it time to repopulate those snapshots. So this helped as well. And when we combined Windows Fast Launch with Image Builder, combined, we were down at the 20 to 25 minute range. For Windows EC2, we thought that was really, really good. I mean, our Linux guys were laughing at us, but 20 to 25 minutes for Windows is pretty good. So we kept going, right? Continuous improvement. Now we're building faster. Now we're bringing the servers up faster. How about deploying the application? I mentioned some folks put the applications directly on their AMIs. We use a tool called Octopus Deploy. And the way Octopus Deploy works is there's an agent that runs on your EC2, and it connects back to the main Octopus server. And it does some registration to let it know that the new EC2 is here. And then based on some configuration, it's going to push the application out to your EC2. So we thought to ourselves, what if we got rid of that push model and turned it into a pull? Right? So what if we know where this EC2 is coming up? What if we forced Octopus to do the application deployment right away? We knew the deployments weren't taking long because the tool told us exactly how long they were going. The logs were quite good for that. But the thought was, what if we just have this trigger go faster? Maybe Octopus is waiting to trigger the deployment. So if we can kind of change that to a pull, and we force them to deploy the application as soon as the EC2 comes up, that would make the deployment go faster and make the application more available, quicker. Problem is this didn't work. And I'm a little reluctant to say it was a failure because this still does run in production today. It just didn't help our goal of going faster. Turns out the triggers were not the problem. Triggers were actually going quite fast. So on the one hand, we learned to measure things before you get too deep in implementing it. But again, I don't want to call this a failure because if you believe in chaos engineering, it's always good to have a backup. So now we have a backup in case they fail. But this was something we invested some time in. Didn't help our end goal of going faster or saving money. So we think at this point we've gone as fast as we can, right? We're building the server faster. We're doing as little as possible when these instances come up. We're launching quicker. What more could we do? So we thought, what if we build them before we need them? Let's build them earlier and just use them as we need them. So we put together our own script to kind of handle this, right? Bring up all our servers, especially in our backup region. By the way, you may notice I'm calling it a backup region, not a DR region. If you're going to go multi-region, active-active, active-passive, the biggest obstacle is stop thinking in terms of DR, right? Forget about DR. Don't have any hesitation to flip to your other region. Luis mentioned earlier, people tend to be the problem more than the technology. Right? Forget about thinking about DR. Just it's a primary and a secondary, and one is just as good as the other. So we thought to ourselves, let's build these EC2s in our backup region, and let's stop them until we need them. So we put together a PowerShell script that would kind of go through the whole environment and take each application. And first, you kind of have to take it out of service and go to scaling group, right? And then once that's down, then you can kind of stop the server. And then as you need them, you can just run the script in reverse and bring it back up. So did this work? Yes and no, right? The script worked. It did what it was supposed to do. But there was it was overly complicated, right? There are a lot of steps involved. I'm oversimplifying it a little bit, but you kind of have to do things in a certain sequence. And if you do it out of order, what will happen is you'll lose the server. It'll terminate. And then you'll end up building a new one, which is not necessarily what we're looking to do here. right? We wanted to have that server be able to go up and down as possible. It's very delicate that way. It required a lot of maintenance, and if we needed to bring applications up in the backup region, we had to know exactly which ones we needed. And then someone on my team would go and run a script to go bring it back up. It was a little too much maintenance. And if you ask anyone on my team, and there are several of them in the audience here, they'll tell you that I'm lazy. I don't want to put in extra effort if I don't have to, right? I want AWS to do as much of it for me as possible. My wife will tell you I'm lazy too, by the way. So what could we do to make this easier? And that's when we found warm pools. Now, warm pools does exactly what we're talking about. It allows you to have these set of EC2s that are built, fully configured, ready to go, and stopped. You don't have to do a thing. And when you auto-scale, instead of building a new server, building a new EC2, it's just going to turn this one on. And if you use it with hibernate mode, it'll even start even faster. It doesn't have to be fully stopped. So warm pools really met what we were trying to accomplish. So we thought to ourselves, before we get to production and our backup regions, what can we do with this? And we said, let's talk about non-prod. I hate spending money on non-prod. Right? Production, I think we all realize we have to spend money to make money, right? You got to invest the money in your production environment. But non-prod, that hurts, especially because a shop like ours where we have many, many applications. And most of them, a lot of them, are not under active development. They're just things that have been built for years, and we do the occasional maintenance and things like that, but there's not active work going on. And so we're just burning money having this non-prod region up. So we thought, what if we just turned all those EC2s off? We're going to turn them all off. We're going to put them all in a warm pool. Okay, and then we're going to set up a CloudWatch alarm that says the first request you get to the load balancer, right? If you get a load balancer request without any EC2 underneath it, you get a 503 service unavailable. First 503 error, trigger a scale-up event on the auto-scaling group. And what's going to happen is it's going to pull this server out of the warm pool and start it up. In our testing, it took about 1 to 2 minutes for the server to come online and actually start taking traffic. In fact, it took just as long to get the server up as it did for CloudWatch to fire, with that 1 to 1.5 minutes. CloudWatch is not exactly real time. But it was really, really fast, and the server came up really quickly, and it was just a minor inconvenience to our developers to understand that the first request may fail. And then we set up another CloudWatch alarm that said monitor number of requests, and if there are no requests within 1 hour, turn the server back off, which basically is just saying scale down. Right? Scale down, server goes back into the warm pool, and it's ready for you there. Now this actually touches on a new feature AWS came out with a year ago. Warm pools has been around for a long time. But what's new is this ability to put EC2s back into the warm pool. It used to be you build an EC2, it's in the warm pool, you use it, and then it terminates, and then a new one came into the warm pool, which was always a bit of a pain. It wasn't something we were eager to do to stress this pipeline of build, use, terminate. But now we have this ability to put it back into the warm pool when it's finished. That's great. You can just use your EC2, and when you're done with it, it just goes back into the warm pool. It's like turning servers on and off as you need them. Now, a few things to consider here, right? Your CI/CD pipelines. It's a little hard to deploy to a server that's stopped, right? So if you're going to be deploying applications and tests, you have to keep that in mind. You have to hook your CI/CD pipelines into your warm pool setup to make sure the warm pool comes up, and then you continue your deployment. Does not work with Spot instances. Now, that wasn't a problem for us, because I mentioned earlier we're not using Spot because we weren't saving enough. But if you choose to, keep in mind warm pools and Spot do not play together. And beware of overlapping alarms. And what I mean by that is we found out the hard way. You'd have a EC2 that's going down because you had an hour of no requests. And it doesn't exactly go down in 3 seconds, right? It takes a minute or 2 or 3. And while it's going down, a request comes in. Now the alarms are overlapping. It's trying to scale up while the server is going down. And what we learned happened is the EC2 would terminate and you'd build a new one, which is not what we want to happen. So you have to keep that in mind as a consideration as well. The results were fantastic. We couldn't deny it. 75% savings on our EC2s in our non-prod environment. 75% fewer hours. This means EC2s going down nights, weekends, during the day when they weren't being used. Again, this is non-prod. It was fantastic savings. So we said, how do we take this to the next step? What do we do with it next? We started doing this for EC2s in our backup region. where we might have one EC2 up running, run a light version, run a smaller version in your backup region, and when the traffic flips over, pull it out of the warm pool, immediately scale up. Sometimes even before the traffic's flipped over, the EC2 is up and running. CI/CD servers. So we use Elastic and Bamboo. There are many CI/CD tools out in the market. Several of them are in the expo if you want to go check them out. Anyone ever get complaints from developers? Hey, my build is in the queue for like an hour. I've been waiting for such a long time, right? So we just started building more agents for our CI/CD tool and just brought them in and out of a warm pool based on the queue depth. More requests, pull some more out. The queue is light, turn those EC2s off. And now had the ability to scale Windows applications to handle that sort of spiky workload I talked about. This was never something we could think of before. I mean, spikes inherently are things that are quick and you have to adapt fast. Windows would take way too long. But as a spot instance, if the server is ready and you just need a minute or two to turn it on, we now had this ability to handle Windows as if it were a Linux or open source application. Some other things we're looking at doing is using it for internal applications or low traffic applications, maybe cutting down on our usage nights and weekends. And we now have the ability to scale pets. So that was great, right? That really met the mark, right? We're now down to a minute to 2 minutes. We're taking advantage of all sorts of auto scaling. Things are going really, really well. We kept looking and said, what if we didn't have to build a server at all? Now, I know when people hear that, the first thing they think of is serverless and Lambda. But before we go there, we need to talk about containers. Now, going back a few years at this point, I remember Luis and I were talking. So a little bit about Verisk. We're both a .NET and a Java shop. We have a little bit of a mixed bag. And our Java applications were already running on EKS for several years already. We had picked EKS as our container management tool. So I remember Luis and I sitting in his office talking about the Windows workloads, and we said, well, what if we took our .NET Framework applications and put them in a Windows container? I remember at the time Windows containers were picking up a little bit of steam and a little bit of traction. So, well, we can put it in a Windows container and run that on EKS. And you wouldn't have to change the application. So we spent some time and looked into it, and it was true, and it would work, but we had some reservations. So for starters, you have to run these Windows containers on a Windows EC2, which means you're still going to wait for that Windows EC2 to spin up, right? It's still going to take some time. Additionally, you had limitations running Windows, right? You couldn't run it on Fargate. You couldn't run it Graviton. And I remember being at reInvent, and I talked to someone that was giving a presentation about Graviton for ECS. And when Graviton ECS was supporting Windows. And I asked, well, what about EKS and Windows? Do you think it'll ever happen? And he kind of danced around the topic and said, well, if you know how Windows works and how Fargate works, I wouldn't hold my breath. You know, he wouldn't give me too much, but he said it's not optimistic. So we started thinking, we regrouped and realized, you know, Microsoft is really pushing everyone to go to .NET Core. And we said, well, what if we just upgraded our applications to .NET Core? And now .NET Core runs on Linux. Now the world is your oyster, right? Now you can run it on Linux host. You can run them on Linux containers. You can run it on EKS, Fargate, Graviton, Spot, whatever you want. It's all available for you. So we took one of our newer applications, and we started going things that didn't require a change, right? It was being new build. And we started moving that direction. And we started moving our applications to .NET EKS. The other thing we looked at, and I kind of call this attempt 2A because we did them simultaneously, was moving serverless and moving .NET applications to Lambda. Now, Lambda is not the end-all be-all for everyone running .NET, right? You have to consider that Lambda has its use cases and it has its cases where it's not a great fit, as we unfortunately learned the hard way as well. Lambda costs take into account 3 different factors, right? The number of requests, how many requests you're getting, how long the requests run for, and how much compute you need. If you don't need a lot of compute, you should be okay. But if you have one request that one day where you've got this Lambda function that doesn't really get a lot of traffic but needs a lot of compute, and one day you've got that massive traffic spike, and you think to yourself, it's all right, it'll cost a little bit more, but you know, it'll be $5 or something like that. That one day may cost you more on Lambda than an entire month would have on EC2 or EKS. And I unfortunately speak from experience because we had several lambdas that fell into that category. Lambdas where that one day ended up being a multi-$1,000 spike that we would have been cheaper had we run on EKS or even on EC2. So Lambda is definitely a great thing to look for .NET, but I wouldn't classify that as the end-all, be-all. In fact, I'm not even sure I'm supposed to say this, but it's in the AWS, the reInvent catalog, so it's open for anyone to look at. I saw they just announced that .NET Lambda now you can run with snap start for Lambda. So it's another benefit for running .NET on Lambda. But not necessarily every use case. Now, I obviously brushed over the hardest part of all that, right? Which is what? It's getting people to upgrade .NET Framework to .NET Core. Right? It's very easy to say this. Yeah, sure, just upgrade your application. And you can run it in Linux and anything you want. Right? But getting teams to upgrade is difficult. Right? We have many developers are very, very busy. They don't have time for all this. So some of our teams did, and some of our teams had a harder time with it. And that's when Chris and I were discussing the AWS Application Modernization Lab, the AML, and they were able to come in, and they're working with us now to help do some upgrades and get our things updated. And Chris, you want to talk a little bit more about AML?
Sure. Thanks, Alex. So that's kind of the full circle, right? Even unintentionally, is that I first met with Louise about maybe talking about a commitment to change the .NET Core to Go, and like, can we help them? And it kind of was a sidetrack of like, wow, you guys are doing amazing things. And I think at the time we said, no, we're good. We got this. We know what to do, right? And then this kind of comes of how can we help, right? In that the Application Modernization Lab, what we're doing for them is that they're committing to a certain amount of workloads that they are moving over to .NET Core, and we're going to help them out with that with resources, professional services, and a cost neutral. Now, not everyone qualifies for that, but the good news is that there's a lot of programs that we have that do similar things. So biggest thing I'm going to say, take away from here is that if you're not already talking to your account team, your AWS account team about modernization and how we can help, definitely have that conversation. There's lots of programs that we have that can help with that. If you don't have an account team, you don't talk to your account team, you probably do, we need to find them, but I can help you with that. We do have some other tools that can help with this. So we have Amazon Q code transformation that will start to automate that process of going from .NET Framework to .NET Core. You can see a lot more presentations about that here at reInvent. We have AWS Apt Container. We have a toolkit for .NET refactoring. And we also have microservice extractor, right? So, oops, went too soon. But those are tools that we can have to help you guys out if you need to. But really, you're not alone with these. Come talk to your account team. We will help you to do the modernization. What I loved about their story, though, is it's not just go to .NET Core. We can use Windows workloads and use other tools to reduce costs. And that is really, I think, where we should start. Because too often, we say, oh, just go to the .NET Core, it'll fix everything. And we know that's not a realistic answer. Same with like SQL Server to Postgres or Aurora. Yeah, it's fantastic, and I know you guys do have some Aurora workloads for sure, but we lose a lot of trust if we just say, just go do something that's easy, and we know that's not easy. So hopefully we get that. Now, we have some time for questions and answers, right? So, but first, a few takeaways, right? So continuous improvement, I hope you heard, is the secret, right? It's easy to say it, but to keep improving that, and to their credit, they kept improving it, always trying to make things better, right? I hope you learned some tips and tricks that these guys went through, and kind of things not to do, potentially. And I hope you realize that there is tools to help you guys to modernize and help you with the things that are not just modernizing, just using AWS infrastructure a little bit more efficiently. Thank you, guys. And we really appreciate if you do the survey.